next part of Unit 4 involves being able to solve exponential functions. You solved exponential functions in the 9th grade, so it's been a little bit of a while. So, on page 17, when you solve exponential functions, your bases have to be the same, and your bases are the big numbers. Okay, then you've got your little exponent of the number up at the top. So the bases have to be the exact same. So the first part is if the bases are the same, I drop them. And I set the exponents equal to each other and solve. This is kind of like when we solved logs and we had logs on both sides. They were the same on both sides, you drop them and you set everything else equal to each other. So for number 1, I've got the same base, which is 5. I can drop them and set the exponents equal to each other. Same thing with example 2. Both of my bases are 10, so I can drop them, set them equal to each other, divide by 2, so x is equal to 4. Alright, number 3, bases are 6. So I can move that 3a over, and a is equal to 2. Alright, on page 18, you have what's called powers to know. To help you rewrite your bases, because they have to be the same when you solve them, sometimes it requires you to rewrite them so that they are the same. So when you have to do that, use this chart to help you rewrite them as equivalent bases. So pause it, get this in your notes, and then hit play. Alright, so for example 4, 5, and 6, we're going to look at bases are not the same. So if you look at example 4, I have 3 to the x equals 9. Well, if you just remember back what we did with logs, if you have something like that, something raised to the power of x, and there's only one x present, you can rewrite it as a log and put it in your calculator. So this one, I could rewrite it and put that in my calculator. When I do that, I get x is equal to 2. Now, we're not going to be able to rewrite them as logs for every single kind of exponential function that you're going to see. So, the way to handle this kind of problem, I've got a base of 3 and a base of 9. I can't write 3 as a base of 9, but I can rewrite 9 as a base of 3. So, I know that 9 can also be written as 3 squared. So I can rewrite all that together, 3 to the x, and I've rewritten 9 as 3 squared. So now my bases are the same. I can drop them, and x is equal to 2. Which is what I got when I rewrote it as a log. So for these, for 4, 5, and 6, 7 through 9, you can either, well, you're not going to be able to write them all as logs. I would go through and go ahead and try to change the base of them all. So for number 5, I can't do anything with the 3. I can't rewrite to make it look like a 27. But I know that 27 can be rewritten as 3 to the 3rd. Now I have the same base. So 3 to the 2x minus 1 equals 3 to the 3rd. So now I can drop my base and set my exponents equal to each other. Add the 1 to the other side and divide by 2, so x is equal to 2. Alright, example 6. Now the fractions get a little bit harder because when you rewrite exponents and you have negative exponents or you have fractions as exponents, the negative exponent means it's going to change the look of it. So if you look at 2 to the negative 1, it became 1/2. So it changed the look of it, it flipped it around. But if you go right underneath that and look here, 1/2 to the negative 1 is 2. So anytime you have that negative exponent, it's going to flip it around and change the way it looks. So if we go back to number 6, I need to look at 4 and 1 over 64. So because I've got a fraction, that means I had a negative exponent somewhere. So I can't write 4 with a base of 64, but I can rewrite 1 over 64 as a base of 4. I can rewrite that as 4 to the negative third, because 4 to the negative third is 1 over 64. So now I have the same bases, and I can drop them. Then I can move 1 over, and I get x is equal to negative 4. Okay, top of page 19. Alright, so I've got 1/2, and I've got 16. So I want to try to rewrite that 16 as a 1/2. So to do that, I can change that into 1/2 to the negative 4. So remember, because I got to make it look like a fraction, I got to have a negative exponent. So now I've got 1/2 to the x equals 1/2 to the negative 4. I can drop them, and I get that. Alright, number 8. I've got 4 and I've got 1/2. I can make 4 look like a 1/2 by raising it to the negative 2. But this time, that 4 has an exponent with it. These are the kinds that you cannot rewrite as logs. All the other ones, you could. This one you can't because you've got variables on both sides. You've got exponents on both sides and variables on both sides. So these are the kind that you have to rewrite. So I've got 1/2 to the negative 2. Now that 4 already had an x on it. So when I rewrote it as this, that is the 4. I just got to put that x back with it. So now I can drop them. And I've got negative 2x equals x minus 3. So I'm going to move my x over. And I get x is equal to 1. Okay. Number 9. I've got 1/3 and I've got 9. I can make that 9 look like a 1/3 by raising it to the negative 2 power. So because that 9, all I've done with that 1/3 to the negative 2 power is rewrite 9. So I've still got this stuff to contend with. So let's see what we've got. We've got 1/3 x plus 2. We've got 1/3 to the negative 2 where we rewrote 9. And we've got 2x plus 3 hanging out. Alright, so I'm going to drop my bases. I've got x plus 2 equals. Now, because I've got negative 2 times that binomial, I'm going to distribute. I'm going to move 4x over, so I have 5x. Move 2 over, so I have negative 8. And x is equal to negative 8 over 5. And if you want to turn that into a decimal, that's fine. Alright, so all of that was just changing one base. Now we got to look at changing both bases. So that's where that powers to know chart will really come in handy. So I've got, example 10, I've got an 8 and a 16. My first thought would be, oh, well 8 times 2 is 16. But I've got to think of exponents. I can't rewrite 8 or 16 as an exponent and get the other answer. So that means I've got to rewrite both of them. If you go back to that powers to know chart, I look in my answers, the colorful answers, and I see an 8 and a 16 here. So that means I can rewrite those with a base of 2, which is the same. So I can rewrite 8 as 2 to the third, and I can rewrite 16 as 2 to the fourth. So now I've got the same base. Gotta remember to put the stuff that's already there with it. Now I can drop them, and I just need to distribute. Okay, now I'm going to get x's on one side, constants on the other. So we're going to go negative 28 is 2x 25 and 25. I can rewrite both of those with a base of 5. So that 125 is 5 to the third. 25 is 5 squared. And I've got stuff that needs to go back with it. So the x needs to go with this, and the x plus 1 needs to go with that one. So drop them. 3x. I'm going to distribute that 2. We'll move 2x over, and that leaves me with x is equal to 2. Alright, number 12. I've got 9 to the x and 27 to the 2x plus 8. So I can rewrite 9 and 27 as a base of 3. 9 can be rewritten as 3 squared. 27 can be rewritten as 3 to the third. So I can't forget the x that goes with the 9, and the 2x plus 8 that goes with the 27. So I drop my base. 2x equals, I'm going to distribute here. I'm going to move that 6x over. Divide by -4, and I get x equals -6. Alright, page 20. Alright, I'm going to focus on 14 and 15 because of the fractions. So, in example 14, I've got 8 and I've got 1/16. So, I need to think, okay, how can I rewrite 8 as a base? That I can rewrite 1/16 as the same base. The only thing that those two numbers have in common is a base of 2. So 8 is going to be 2 to the third. Now because 1/16 is a fraction, I got to make it a whole number. That's going to require a negative exponent. So 2 to the -4th. Alright, I'm going to bring down the stuff that's already there. Drop the 2's. Distribute out. Get 4 to one side, that 4x, gives that 9 to the other side. And I'm going to divide by 10. And I'm just going to leave it as 13/10, so you can turn it into a decimal if you need to. Alright, last example. 125 and 1/25. So, automatically I know I can do something with 5. So 125, the easy side, is just 5 to the third. That 1/25, I know I'm going to have a negative exponent because it's a fraction. So 5 to the -2.